Okay, so as I said, I'm representing the University of Pittsburgh. We have folks from several other universities online with us today. What I'm going to do here is to play ringmaster and lead things, but several of my colleagues from around the country will be telling you various aspects about their programs and about the field. Basically, what we're going to hope to do today is to sort of give an introduction to why biomedical informatics, and maybe in a slightly backwards case, we'll then go on and talk about what biomedical informatics means and really the range of possibilities. And we'll have some descriptions of each of the graduate programs. We've got representatives from several. I'm going to ask everybody to speak for about 2 minutes to their programs, and I will start interfering if they go more than 2 minutes. And then we'll talk a little bit about how you might go about, if you're interested, consider pursuing graduate study. So with that, I'm going to hand things off to the first person who's going to speak, Kim Unertl from Vanderbilt.
Harry, did you want to bring up the slides?
I thought I was sharing the slides, and there you go. Thank you, of course. There you go. So we just mentioned the outline slide here, which I just spoke over that gives you the outline of what we're going to do. And here is the next slide where Kim is going to talk a little bit.
Great. Thanks, Harry. I'm Kim Unertl. I'm the Director of Graduate Studies for the Biomedical Informatics Master's and PhD program at Vanderbilt University. It's great to talk with you all today. So just to start off, as you've hopefully been learning already this summer through the programs that you're participating in, there are so many different opportunities in biomedical informatics. And one thing we definitely want to highlight is that although the programs you're participating in this summer, are located in academic institutions, really biomedical informatics spans all different disciplines. And so there are many opportunities, not just in universities, but also in industry as well. So I feel like, as we kind of all know, there's so much health data that is being collected every day on our phones, as we're using apps, as we're using different features of different online tools. And so the amount of health-related data and information that is out there that we can build new tools and new ideas off of is really, at this point, almost limitless. Harry, I'll hand it back to you.
Thank you. And one of the things, though, that we've come to realize in recent years, and why it's so important that we work with increasingly diverse groups of people, is that bias is a real concern with all of these models. And as we start looking at data, we are constantly asking ourselves questions about whether the data really represent the people for whom we might want to be doing the work and providing care. And we want to make sure that we have the right data to address the right problems. And as you can see from some of these headlines, there's a definite awareness that there are difficulties with some of the ways that data is used currently, and it may disproportionately or inappropriately harm certain groups. And we are really trying to work towards approaches that can, if not completely solve this problem, at least minimize the costs and the risks. And so that's an important part of what we're spending a lot of effort on these days, and why we're, in many ways, why we're talking to you here today. And to elaborate on that point, I'm going to hand it to Bill Hirsch.
I'm Bill Hirsch. I'm from Oregon Health and Science University. I apologize for my voice. I'm a little under the weather, but I wouldn't want to miss this. And I see our interns in our theater there. I wish I could be there with them. Anyways, we recognize that in our field, like so many scientific fields, that diversity is important and something that we must address. There's plenty of research out there that shows that diverse teams get better results, bring different ideas to the table, increasing innovation, solving problems faster, and increasing research output and its impact. As such, we need a climate of inclusion in organizations where people across the board feel fully accepted and can apply the full spectrum of their talents. So this has actually been documented in many scientific fields, including our own of biomedical informatics. Our doctoral degree programs are not as diverse as they should be, and the improvements have been slow. And gender representation, while improving somewhat, is still not good. So there's still plenty of work to do, which is part of the motivation for the National Library of Medicine program this summer. Turn it back to Harry.
Thank you. Alex?
I'm Alex Alexienko from Medical University of South Carolina and Clemson University. And as former NIH Director Francis Collins said, the biomedical informatics and data science is one of the hottest careers of the 21st century. And this is really illustrated across the sectors where these career opportunities can be found. Obviously, getting an advanced degree, you will position yourself for a research career, so you will be welcome at many academic institutions if you're interested in developing new methods and techniques, or applying these techniques to advance the knowledge of life science and medicine. Healthcare with immediate applications of your biomedical informatics data science skills in operations of medical centers. Obviously, that's an obvious path for you. In industry, in drug development companies, in companies that use digital medicine and deliver new technologies for applications in medicine, you'll find those. And in various regulatory or research government organizations, whether federal or state. Next slide.
Thank you. Titus? Titus, are you there?
I am here. Thank you. So why is informatics a great career? Alex just talked about how biomedical informatics can be applied in many areas. Many of these areas are listed here that I don't want to go into. The key also is it gives you career flexibility. And the most important thing about why it's a great career that I would say is it allows you to make impact. You use the latest advances in artificial intelligence, data science, and computation to address the really big problems we have. It's fairly prestigious and has good pay depending on where you are. You will never have to worry about finding a job. There's plenty of opportunities, and there's pretty good support when you're in school, for instance, through the T15 program, through the training programs we are talking about. You make a difference in people's lives. Some of you who will go into this field will develop interventions that are at work in hospitals, in clinics, in public health agencies. And so I think it's a very satisfying and impactful career. Thank you.
Titus, if you could just tell us about the details on the next slide here as well.
Yeah, so this is a very good site that was published not too long ago, and I would encourage you to read some of the blurbs about the people who are profiled here. These are real people who have real training, received real training through the programs we're talking about. They range from very junior people to very senior people in the field. And I would just peruse the set of YouTube videos and kind of listen to some of the stories, because they make the potential things you can do with this field very intuitive, and maybe you'll even identify with one or the other person. Thank you.
Great, thank you. Peter.
Thank you. Biomedical informatics uses effective biomedical data, information, and knowledge to improve human health. This is a paper I was part of, and the key thing here is that it's a very broad discipline. No matter what your talents are, there's a way for you to use those talents to strengthen the field and also to help mankind and human health. I mean, you can make a living a lot of different ways, but in biomedical informatics, you are helping people. And whether you're a doctor at the bedside or whether you're creating algorithms that help doctors practice better medicine, you are actually taking care of patients. And by taking care of patients, you make a real difference in people's lives and their families. So the key is that it's a really important field that can have a great impact, as many of my colleagues have said. And it's also a great group of people to work with. You know, honestly, the older I get, the more I want to work with people I enjoy. And these people that are on the screen with me are my colleagues and friends. And I've known them for quite a long while and enjoy seeing them and working with them. And when you're in a field like that, it enriches your life in general. We want the best and the brightest of you to be part of this. So if you consider yourself someone who wants to change the world and one of the best and the brightest of those, come join our programs. We would love to have you. Thank you.
Thanks. And just to be very concrete here, I want to point out that this slide also lays out the subfields of what we call biomedical informatics, which range from areas in bioinformatics and imaging to clinical informatics and public health informatics. We're often lumped together as health informatics, where we talk about applications in healthcare or about public health. And also environmental informatics, where we talk about large-scale environmental questions. And now we're going to have a few slides where we'll tell you a little bit about some of the types of applications and kind of works that people do in these various areas. And to start that off, I'm going to ask him to tell us about this work.
Right. So I'm going to dive in first to bioinformatics and precision medicine. So sometimes you'll hear biomedical informatics as the overall field called bioinformatics, but it's actually a specific subdiscipline within the field. And one way to think about this area is think about it as being personalized medicine. So how do you tailor treatments? How do you tailor medications to the individual? And it really comes down to combining genetic information, environmental information, medical data all together to both come up with population level insights. So how do different groups, genetic characteristics and other characteristics, how do they respond to certain medications and doses of medications, and then also individual insights based on those population level insights. It's really at the core, bioinformatics is really about data-driven insights for healthcare delivery. I'll send it back to Harry.
Great, thank you. I believe we have James Zhou on from Stanford. James, could you tell us a little bit about this work? Introduce yourself, please. Okay, maybe not. I'll take over then. So this slide is an example of imaging informatics. And of course, in medicine, there's a lot of different types of imaging that we have going on, whether it's X-rays or CAT scans, or in this case, microscopy images of cell samples that are taken for biopsy. And currently these images are reviewed by trained physicians or other professionals who try to look for patterns, again, in this case, to find cell shapes and sizes that might be indicative of different kinds of cancer, and they're going to label them. Is this an adenocarcinoma or a squamous cell carcinoma or some other type? Well, there's been a huge amount of effort over recent years to use machine learning, in particular deep convolutional neural networks, to classify these images into different types, so we might be able to more quickly, or perhaps sometimes even more accurately, process the files to determine, is this sample cancerous? What sort of cancer might it be? And then how can we understand what's going on with the patient? So in this particular work, they were not only classifying the cancer type, but they were trying to look at different subtypes of the transcript transcriptomic profiles, excuse me. And so there's a lot of work along these lines going on in a number of different imaging areas. Okay, this next one was for me. Clinical informatics is another field where there is a lot of work going on. And essentially this involves really two different strains of work. One is making electronic medical records and clinical data systems more usable and effective, which you can see on the right as an example of a display of some information that people might want to see in an EMR. This was some work done by colleagues at the University of Utah. And on the left-hand side, you can see some example of learning from clinical data where they looked at drugs that were prescribed together in clinical trials. And you see drugs all in a circle there, and those that are connected by two lines were given together in clinical trials. And on the right, though, you see what happened in real life, which drugs were prescribed together. And you see that, of course, many, many more combinations are given in life than real life and in practice than we have the ability to do trials for. And this is why there's a huge push to learn and gain insights from observational data, because we can't do all the randomly controlled trials that we might want to do. But if we look at what's happened in the real world, we might learn some things about what works well or what doesn't and when. And so this is a big push with a lot of efforts. This next point here at the bottom, this idea of using machine learning to identify patients with undiagnosed rare diseases. It's a real problem when you've got a rare disease of giving a name to it or coming up with a specific diagnosis. But if we have enough patients with enough data, we might be able to look at the presentation of symptoms and other information to figure out who matches with which disease. And again, this is something that could be very useful in clinical care. These are just a few of the examples. Now for this, I'll ask Bill to talk a little bit about public health informatics.
Sure. So another area of health is public health, which focuses more on populations than individuals. Obviously, individuals make up populations, but there's a real focus on populations, and oftentimes public health work is done by government agencies, whether federal, state, or local. And there's quite a role for public health informatics. It obviously came to the fore with the COVID-19 pandemic, but public health informatics has been around long before that. And so doing things like epidemiological modeling or outbreak prediction, trying to predict, especially make early predictions when the number of cases is small and you can still intervene effectively when a disease is spreading. And other kinds of studies looking at different factors related to COVID-19, the impact of vaccination, the impact of introducing different treatments and so forth. And really, even though we talk about these areas separately, they overlap with each other. For example, a big part of public health informatics now is tracking the genomes of the SARS-CoV-2 virus that causes COVID-19. So it kind of ties public health informatics back to bioinformatics. I'll turn it back.
Thank you. And now we're going to hear about the various programs in some detail. So I'm going to start with Peter from the University at Buffalo. And please keep it to 2 minutes.
Oh, very quickly. Yep. Thank you very much. So we're very proud of our program. We have a milieu, educational milieu, which includes an undergraduate program, master's degree, PhD degree, a postdoctoral fellowship training in science, and a postdoctoral training program that's an ACGME accredited clinical informatics program. So there's a rich group of people for you to work with within the department. Beside the faculty, you have about 35 faculty and about 75 people in the department. The different divisions in the department are clinical informatics, bioinformatics, public health informatics, biomedical ontology, which is fairly unique at our place, and socio-technical and human-centered design, which does a lot of the human factors engineering in the context of the way these systems that we create work within the healthcare environment. We would be very thrilled to get your applications to our PhD program, and would look forward to you, visiting us and taking a look at what we do. one of a number of excellent programs in the country. Buffalo is probably known best for chicken wings, but also Niagara Falls is right by, but we're nestled in between two Great Lakes. It's really beautiful here in the summer. We get some snow in the winter, it's true, but they handle it really well here. So the living conditions are actually a lot of fun and the people get along well. Mostly everybody works in teams within the programs that we have here, and that's been very, very popular for people. Also, we run the annual boot camp program, which has been taken up by this year by 373 people and includes all of the clinical informatics fellows, a bunch of the T15 people and people around the country. And we also hope you'll take part in that. And I'll leave it to my next colleagues. I'm sorry if I went over. Thank you.
Thanks, Peter. That was just about perfect. Next, I believe we have Stanford University. James?
Hey, everyone. Hi, can you hear me?
Yes.
Hi, this is James Zoe. I am a faculty at Stanford in the Department of Biomedical Data Science. So it's great to meet all of you. So we have a really exciting and diverse department with over 60 participating faculties. And the faculties work on a range of different research areas, including everything from clinical informatics, these more translational bioinformatics, as well as like more genomics, basic biological discoveries, all the way to like later stage clinical trials and designs and deployment. Right. And there's also a lot of research in machine learning and AI in the group, which is an area that I do. My group does a lot of work in. So we have quite a well-established program. It's been around for over 40 years as a part of this PhD program and also master's program for graduate training in biomedical informatics and data science. And we also have a lot of collaborations, interactions with other parts of Stanford, including computer science, the School of Medicine. So there's really a lot of great opportunities and exciting opportunities for students to work on quite diverse projects. It's also a very collaborative environment.
Great. Thank you. Next, I'm going to ask Titus Schleier to tell us about the program at Indiana.
So hi, everybody. I'm from Indiana University and the Regenstrief Institute. If you haven't noticed by now, we're all trying to sell you on a career in biomedical informatics. But second, we're also trying to help you figure out what is a great program for each individual person. So just a few highlights about our program. We are focused on public and population health informatics. Our research is very multidisciplinary. And our main priorities are trainees are number one. So we will help you to the best of our abilities to succeed in our discipline. We want you to become leaders. Some of our previous graduates are in early leading positions. We also hold our faculty to high standards of mentoring. In order to have a great training program, you need great students as well as great mentors. And a particular feature of Indiana and the environment here is that you get to impact the real world. With that, on to the next one.
Thank you, Titus. Alex.
We have a relatively young program that started in 2017. But we've already seen a number of graduates from our program that have taken roles both in academia and in industry. We've seen our graduates starting their own companies such as AI Medica, or joining larger companies like GeneDx, a premier genomic diagnostic company, and Frisia, a company that takes patient intake. We are a traditional, we offer traditional training in biomedical informatics with focus on precision medicine, population health, and clinical translational informatics. And we enhance this training by our connections to the mathematics, statistics, and engineering world through our partnership with Clemson University. We focus very tightly on the public health aspect of biomedical informatics. And I also wanted to highlight that one of the assets in our program is the NII Hub that continues to grow, and it currently has over 310 members and delivers consultations on an ongoing basis, and is preparing to have our third AI summit detailing applications of AI in health and medicine. Our NLM-funded component of our training program further focuses on applications of biomedical informatics and data science in health equity problems. We prepare our trainees to make an impact in communities such as our own state, South Carolina. And we do this by offering them opportunities to understand really deeply and experience the working with health inequities, but also have them participate in career readiness training specifically designed for academia, such as teaching, mentoring, and applying their skills in biomedical data science and informatics within the communities. Next program.
Great, thank you, Alex. Going to pass it off now to Bill Hirsch.
Thanks. So our program, like most of the others you've heard about, is focused on training individuals for careers in academia, professional careers, research careers in this field that's at the intersection of health and biomedicine with data and information. Oregon Health and Science University is in Portland, Oregon, and our program has a strong commitment to diversity, equity, and inclusion. Our program is organized, our educational program, into two majors. One is called Health and Clinical Informatics, and the other is called Bioinformatics and Computational Biomedicine. Hopefully you know what those terms mean from the previous slides. In both programs, we offer a PhD and a master's degree. We also offer a graduate certificate in the Health and Clinical Informatics program. The graduate certificate and the HCIN masters are online. Everything else is on campus. Like many of the other programs, we have funding available. We have our college undergraduate summer internship. A number of our interns are attending this talk today. And then we hope that some of them may go on and join our National Library Medicine Training Grant, the so-called T15, that funds PhD students and postdoctoral students. In the lower corner, you see a picture of the famous OHSU tram that rises up from the river near downtown Portland up to our campus. And you see in the background Mount Hood, about an hour's drive away. If you were to turn around and drive in the other direction, you would reach the ocean. So work-life balance is an important aspect of our program. If you seek more information, if you want more information, you can visit the links here for our program, our blog. You can follow us on Twitter, and you can also email me. I'm happy to answer any questions. Turn it back, 2 minutes.
Yeah, that was perfect. Thank you. Thank you, Bill. Now I've got to hold myself to 2 minutes here. University of Pittsburgh, we don't have oceans, we don't have mountains, but we've got rivers. So that's what we're known for. You can see our mission statement there, which is pretty similar to what other fields programs do. I want to just tell you about a couple of recent projects that give you a flavor of some of the things that have been going on in our world. On the left, you see the Learning Electronic Medical Record, which tries to predict which items of information might be of interest to a physician when they're viewing a given patient. And this is work done by Andy King and Luca Calzoni as students and a bunch of us. And one of the things that we did was to use eye tracking to help us figure out what physicians were looking at when they reviewed notes from various patients. We have a knowledge graph that combined information extracted from the literature with evidence to find out which drugs were causing problems or interacting with each other. Below that, we have a map of schizophrenia protein-protein interactions. It was done by my colleague Madhavi Ganapathiraju and some colleagues. We are also at Pitt very much involved with national research efforts, including PCORNet, which is a large consortium effort to make lots of observational data available, and the National COVID Cohort Consortium, the All of Us program, which some of you might have heard of. And we have strong ties with groups like HubMap and CENDNet, and the Midas Coordination Center, which are big team science efforts. Like other programs, we've got alumni in all sorts of interesting places. And please do get in touch if you have further questions. Would love to try to be able to help you with any questions you might have about this whole process. So with that, I'm going to hand it off to our final program for the day, I believe, which would be Vanderbilt.
Thanks, Harry. So I'm here from Vanderbilt University, which is in Nashville, Tennessee, where we're having thunderstorms right now, which is why it might look like I'm sitting in a dark room. I am. So our degree program has a lot of the same focus areas as other programs. I think in terms of focus areas, we have the biomedical data science space, clinical informatics, the bioinformatics and precision health area, a strong emphasis on health equity across the organization, and then a focus on people and organizational informatics, including user-centered design, implementation science, and how to actually get all of these wonderful innovations that our students and faculty and researchers are producing into actual clinical practice. And so we really emphasize students having a strong foundation across these different disciplinary areas and then building their area of specialization based on their interests and their research goals. In addition to our MS and PhD program, I also direct the Vanderbilt Biomedical Informatics Summer Program. So if after this summer next year you're thinking, oh, I would really like another research experience in informatics, we'd love to hear from you and kind of help you with that next step in your journey. But I'm always, as everyone else who's been talking today is available for questions about applying to graduate school, about thinking about which of these wonderful programs might be the best fit for you, and always glad to answer questions on these topics. Harry.
Great, thanks. So now we're going to talk a little bit about what the process looks like and what it might mean to go to graduate school or to go through the application process at the very least. And so I'd like to ask Alex to start us off talking about this.
Yeah, so what to expect? So a typical program would take 4 to 5 years, depending on your level of preparation and what exactly you're doing. Didactic part, coursework, taking the classes and learning stuff, that's going to be 1 or 2 years, depending on where you're coming from. A lot of people are coming with a good preparation in quantitative fields. They may require less coursework and they would focus on more on the biomedical domain problems or more in the domain-specific applications and foundations. Others will require more comprehensive background, so it may take a lot more in learning to code or learning the necessary math, stats, and other areas. Then these 1 to 2 years of didactic work follows with your main studies, which are research. You would work with a dissertation advisor and form a committee of advisors, typically from multiple disciplines, to advise you and guide you in developing a substantial research project. A PhD is a lot about an experience of leading a large project that takes more than just a couple of months to complete. Typical programs and what to expect from them, they would fund you by providing you with a stipend and tuition. They expect you to be doing well in the program, but in return, they will try to support you. You will learn a lot. You will learn both the hard skills in coding, data analysis, modeling, but you will also learn a lot of soft skills that will really make you great at this in interdisciplinary, multidisciplinary field. You will learn how to interact with people with different skill sets than yours and develop a common language and communicate with clinicians and data people and more quantitative people. You will learn to write, present, And hopefully you will also learn how to teach what you know to others. Next slide.
Thank you. So, is this for you? And this is, of course, a tough question to answer, but this is some thoughts I've had on this that's saying, if you're interested in working on computing tools for improving health and helping foster research, then this might be something you're interested in. Coding is going to be a big part of it. If you like learning new things, doing a lot of reading and writing, these are all a big part of the job and part of what we're looking at, because we all know that we have to not only do good research, but we have to tell the world about it and communicate what we've learned to our peers and to folks outside. Are you self-motivated? This is an important factor that in graduate school, nobody is going to be telling you, here's what you have to do today. You've got to be taking a role in charting your course and figuring out where you're going to go with it. But yet at the same time, we've heard a little bit of this today, but we all have to work in teams a lot of the time. We have to collaborate with others. I work with physicians, I work with epidemiologists, I work with other kinds of scientists. And so a combination being self-motivated, but working well and learning from others is an important part of the job. Working hard is also part of it. We do expect people to really try to push themselves to learn. And this isn't about hours necessarily so much as about time in terms of putting in the thought and really tackling hard problems and thinking hard about them. And finally, one of the things that we find is that there are people who really love the idea of being in the medical world, but they don't necessarily want to be a physician. And so this is where biomedical informatics provides a great opportunity. As I said, I work with a bunch of physicians. I get to learn about the work. I get to feel like I'm contributing to it. But yet I knew from a very early age, I did not want to be a physician. So this is a nice alternative approach that I enjoy very much. So with that, want to move on to Kim to talk about some of the mechanics.
Sure. So hopefully we've got you interested in getting involved and going further with biomedical informatics graduate studies. And you might be asking yourself, like, what comes next? You're already doing this first step of trying your hand at research. You might want to continue that during the academic year. But over the next few months, if you're going to apply to graduate school, there are some tasks to start working on. First is identifying the programs. There's the ones that have been presenting to you today, but there's a whole list of other programs that I think we shared in the slides earlier. So think about different programs, where they're located, how the fit is for what your interests are, if there are faculty doing research in the areas that you're interested in, all of those kinds of topics about kind of thinking about if this is going to be the right program for you. You also, for every graduate program, are going to need some recommendation letters. So lining up probably 2 to 3, depending on the program, people who can write you strong recommendation letters is a good thing to just have that lined up, so that then as you start putting together your application packets, as you start having identifying deadlines, that you're able to just call in those people to send in letters of recommendation for you. And I just want to be clear, it's always okay to ask somebody that you're asking for a recommendation if they can write you a strong letter of recommendation, because you definitely want to give the strongest possible representation of you in your application. The other component that is often typically required in most graduate school applications is a personal statement of some kind, talking about your past experience, why you're interested in graduate school, what you want to accomplish, and why that graduate program, from your perspective, is a good fit for you. So what do you want to accomplish by going to graduate school? Most programs have deadlines that are either in December or in January. Do make sure that as you look at programs that are of interest to you, you're very clear on what their application deadlines are. And then typically somewhere between January and March, there will be interviews and then receiving offers from different programs. I'm also going to drop a link in the chat to an overview that I put together of the application process for students in my summer program that might be helpful. And Harry, that's back to you.
Great, thank you. Let's see, is James still on? No, I guess I will take this one here. So I think we covered a little bit of this here, but just to reiterate, the personal statement, you're going to write something here, you're really going to want to make sure that you know what you're talking about and what the program is. I know I've seen statements from applicants who talk about how they really want to go to Pitt's bioinformatics program and we're the biomedical informatics program. So if you call me the bioinformatics program, I'm going to think you didn't bother to read the website very clearly and you haven't really understood what it is we do and what our program is about. So make sure that you communicate clearly that you know what the program is about and also that what you like to do. What do you want to do with it? Why do you want to do it? The more specific you can be, the better. Now, that doesn't mean we expect people to be able to make a proposal for a coherent body of research that could lead to a PhD in the space of a page-long personal statement, but I'd like to hear something that convinced me that you've given some thought to what you want to do and that this is the right place to do it. Otherwise, I'm going to be a little bit concerned that maybe this isn't really for you. In terms of recommendation letters, you really want to get people who are familiar with what you can do, who've worked with you, who can talk about your skills, your motivations, your abilities, et cetera, and really to make sure that you can get folks to write you letters who can paint a picture of you as a capable and strong student and potential researcher so that we can really be sure that, again, you're somebody who's likely to be successful in our programs. And this is why it's a good idea if you can, and you're all doing this now, but to be involved in research as an undergraduate, because if you can do it as an undergraduate and you learn a little bit about what's about and you understand the kinds of things that we do and you've done well with them as an undergraduate, there's more of a chance that you'll be able to do well as a graduate student. And so this is definitely something we will be looking at in letters. And if you have a good experience this summer, then get your mentor from the summer to write a letter, and that could be very helpful. Next, I want to go back to Bill.
Yeah, so there's a few things to remember to not overly focus on. I mean, obviously grades are important. Everyone who looks at your application is going to look at your grades, but it's not the only thing, especially for a PhD program, because the goal of a PhD program is to do research. So if you have experiences as an undergraduate doing research experiences in an internship like this, that can be very helpful as well to complement what your grades are in your courses. And remember that a lot of graduate school is not taking courses, but it's doing your dissertation, doing research, and advancing the field and hopefully your own career. Some of you may ask about GRE scores. I know that many programs, including ours, no longer require the GRE exam. You should look into that to see which programs require that. And obviously, if they do require it, you'll need to take it. And there are some application fees. They're usually not much, but many programs will waive fees upon request if it is truly a financial hardship for you. So these are some areas not to focus.
Great, thanks, Bill. And so that's really the end of the formal presentation. We have listed the addresses of the programs here. You can go to our websites to learn more about us. There are also several other NLM-funded programs nationwide that we haven't had participation from today. Not everybody could be here, but so these are other areas, schools. You can check that link at the bottom to the NLM to find other schools with programs you might be interested in. There's a form listed at the bottom of the page. I will put that link in the chat. If you fill out that form and tell us you're interested, I will try to distribute that information to folks on this call or to whoever you might be interested in talking to. At this point, I would like to open up for questions from any of the participants, anybody here who's got anything they would like to know more about that we haven't already covered. Big silence. Or anything any of my colleagues would like to say that they didn't get a chance to mention before?
Maybe you could put your slides down so we can see their faces. Maybe that would be better for them to, respond.
Happy to do that.
Oh, just stop sharing. Yeah. So any questions from you guys for any of us or in general? Anybody completely convinced they want to do this for a living now and can't wait to put in their applications?
Yeah, I want to do it. No, actually, I was going to ask a question to some of our colleagues. Not every university or college has a medical school, which is typically where most biomedical informatics programs live, although not all of them. If students are at colleges, what kinds of projects might they find that they could go look at and potentially get involved with to gain experience and to also increase their resume?
It's a great question, Bill. I've got some thoughts, but I'll let others go first.
I was going to say that summer programs like these are excellent opportunities to get involved, but there's also a fellowship at the NLM that people can do during the summer that people can apply to. And we've had some of our undergraduate students go and spend time over the summer at NLM and really have enjoyed it.
There is a message in the chat.
Yes, are there internship programs? And as a bio undergraduate major, what can I get to know to get to know the informatics side of biomedical informatics? And so Bill sort of raised a really good point that if you're at a place with a medical school, you might see if there's a medical school, there's a biomedical informatics department locally, then you might be able to talk to some people there. I would also say, take a look at what's going on in your school's Department of Computer Science or Information School, if you have something like that, because there are often people working in those departments who are doing work that might be directly related to biomedical informatics or might be using similar techniques such as machine learning. And so you could get involved with people and research from those areas. And that, at least from my point of view, that's equally valid. It may not get you sort of directly into the biomedical informatics field, but it's certainly something that you could consider and get some good experience from. In terms of other internship programs, there are people who have different things that are going on at different institutions. I'm not completely familiar with all of these, but there are things, for example, that the National Science Foundation sets up the research experience for undergraduates programs, which might allow you to do research in some other programs and some other fields that and other schools that might also give you more perspectives. There are a couple of other questions here, I think, that are good ones, so I'm going to read them off here. One, outside of professorships, what kind of career opportunities are available to having a PhD as opposed to just a BS in biomedical informatics?
So a BS just says that you know about a field. A master's will say that you have some skills in that field, but a PhD says you can innovate in a field. And so if you're even thinking about corporate work and you want to be able to innovate in the corporate world, that's usually they're giving that to people who have PhDs these days. And then a master's degree will help you to be able to work in a discipline within an industry. And there's many industries, not just IT industries, but pharma and other places that are very interested in our graduates. I would also say that for people who are interested in professional schools like medical school, nursing, pharmacy, that taking a master's in biomedical informatics is an excellent way to improve your ability to get accepted to those programs.
I want to add to what Dr. Alkin just said. With a bachelor's degree, you become an expert in answering the question what the field is about, and what the different important techniques in the fields are. With a master's, you start becoming an expert in how these techniques are applied, and where to find the techniques to solve a particular problem and a problem that you have at hand. And with a PhD, you become a master of why a certain technique works better, why a certain technique should or should not be applied to a particular problem that you have at hand here.
I think, just to piggyback on this question, that I think something that is probably true for all of the programs that are here today is that our graduates really do split across different areas now. We have a number of people who stay at universities either as just purely doing research or doing research and education. But we have a large number of graduates who go into industry. And with a PhD, it gives you more control over the direction of research than if you have a master's or a bachelor's degree. We also have graduates who go into government service. There are many different parts of the federal government and other nonprofit organizations that benefit from biomedical informatics expertise and are looking for people specifically who have at least a master's level of education or a PhD in biomedical informatics, often to lead teams working on specific project areas.
Yeah, I want to take a minute for another question that came up here. How is biomedical informatics from biostatistics? That's a good question. I'm going to take a stab at it and see if others want to disagree or add to what I say. But biostatistics is definitely a field where we could consider to be well within the realm of biomedical informatics. We do a lot of work with statistics, whether it be on the observational data we would see, for example. I think that there are two differences that I would think. One is that we might tend to work a little bit more directly with clinical data and thinking about what it means to represent different conditions and how to interpret the data. And also, I think it's the question of where we want to make our contributions, that we're not necessarily making contributions on the statistical methods. Like a biostatistician would really be trying to come up with a new statistical test or solving a problem that statistics hasn't been able to solve beforehand. We're more looking at using statistics as a tool. But I will say these are broad generalizations. We, for many years, had a biostatistician in our department, and he did work with the rest of us. And so, does anybody else care to draw a line between those two fields?
I can chime in briefly. Biostatistics is mostly focused on statistics, which is mostly focused on making sure that, for example, when you do any kind of research study, that the results are statistically significant, that you can draw inference from the studies that you've done. Biomedical informatics is probably broader than that. There's a lot of biomedical informatics that doesn't involve doing computation with numbers. We install systems, we look at them, we look at how users use them well or not well. We look at things like communications between people, whether it's patients and clinicians or people and other people. I think that biomedical informatics is a little bit broader, and in a sense, data science is the same way. The data science and biostatistics are really important fields, and they're foundational to informatics. But those fields tend to focus on taking the data and analyzing it, but then the next step of sort of moving it out into the real world and evaluating how well it works, I would argue is more in the realm of biomedical informatics, but there might be people who disagree with me.
It's interesting. I'll give a simpler definition just for fun, but I agree with what everybody said. I'll just point out for my colleagues' sake that the Association of Clinical and Translational Sciences has been working between the informatics SIG and the BIRD SIG, which is the biostatistics epidemiology one, to come up with joint advocacy statements and to define the overlap and differences between the fields. What I think one of the easy ways to consume this is that most biostatistics programs train people in using administrative data sets like claims data, and most informatics programs concentrate on using EHR data for their research programs. Some of the methods that are defined as new methods in the biostatistics world are about pure math, and many of the models that are created by biomedical informatics have a deep understanding of the data, and that helps us to be experts in data governance, data provenance, and also in ways that we use the data primarily because we understand how it was generated, where it came from, how all the changes that were made to it. And so there's some fundamental differences in expertise between the two groups. And I think that it's becoming clear to everybody that there's utility for both an application for both fields. Anyway, I don't know if everybody agrees with that or not, my colleagues, but it's been an interesting set of discussions in the ACTS world.
Okay, we've got one more question here, and I think maybe we'll try to wrap it up after that. But it says, as a data science graduate student, what would it look like for me to be working or doing research in bioinformatics? And I'll take that in another question. And any programs for recent graduates who haven't yet been able to get into graduate school? Real quick, I think whatever your background is, you'd be coming in, you'd be taking some classes, you'd be doing a lot of reading to learn about a field, digging in and probably getting your hands dirty, working with some kind of data, trying to figure out, understand that data, apply some methods to it, working with clinicians to understand what's going on, or other collaborators who know the data domain better, building out methods, testing things, running experiments, writing papers. And then in terms of recent graduates who haven't yet been able to go to graduate school, I would suggest a couple of things. There are internship programs at the National Institutes of Health, which are great ways to get experience. Another thing you can do is to try to look for staff positions. We often hire people, and often folks right out of undergraduate, as staff programmers or people who are going to help with our projects in various ways. And that's a good way to get some research in before you go off to graduate school, or to get a job in industry that might be relevant. These are all things that you could consider doing. Anybody else care to elaborate quickly so we can let folks go soon?
I think you said it very well.
Mm-hmm.
Okay. All right. In that case, I think I'm going to try to close it down here because it's a little bit after 3, and I want to respect everybody's time. Really thank everybody for attending and listening. Hope it was useful. Thank my colleagues for participating, and please do reach out if you have any questions that we can help with. And best of luck, and enjoy the rest of your time in your internship programs.
Bye-bye, everybody.
Thanks.